Yeah, thank you very much, Ramin. Hello, everyone. Once again, my name is Stefan Gibele. I'm solution engineer and team lead with Softing. And today we are going to talk about how to collect data from Synomeric 840Ds. But before, maybe one question, why is data collection important? Let's assume that your company asks you to introduce machine learning or to train your AI model, or simply, like we do it today, simply to visualize your data to monitor if the production targets are reached. All these use cases have something in common. They all need high quality data in the beginning. And to overcome this challenge, Softing provides multiple solutions for it, like the 840D Edge Connector. The 840D Edge Connector provides you access to Siemens Synomeric 840D solution lines as well as for power lines, and it provides easy access through well-known communication protocols like OPC UA and MQTT. Using Edge Connector 840D allows you to access values from the access, from the drives, program data, conditions, and tooling. I will come back to that later on in the practical demonstration. And the Edge Connector 840D is also a lightweight Docker application, which allows you flexible management and deployment options. The configuration is done via the web interface or the REST API, so you don't need a separate software for it. You just need a browser, and that's it. Softing does not only have one edge connector, we have multiple edge connectors, each having a different source, like the edge connector Modbus, who is collecting data from Modbus PLCs. We also have one for Siemens, specifically designed for Siemens PLCs like S7 300 or 1500. And we also have one for FANUC CNCs. But as mentioned earlier today, we focus on the Edge Connector 840D, allowing you to access data from power lines and from Synomeric solution lines. Briefly, the setup explained. So you have the Edge Connector 840D in the middle, and by connecting to a Synomeric solution line, which is the newer line from Siemens, you will have a Ethernet connection, and this is made via the interfaces X120, or you can also use the X130. If you use the X130 interface provided by the Synomeric, please ensure that you enable the firewall port in the settings of the Synomeric. This is how it looks in real life. So this is the X120, which I explained earlier, and this one is the X130. You can use both, but if you use X130, you need to enable the firewall. On the right side, you see a picture of it. X120 would be where the yellow cable is plugged in. X130 is where the white cable is plugged in. When we speak about power line, it is similar but not the same. Why? Because the power line does not provide Ethernet. So they just have serial bus communication because of the age of the power line, which was mainly manufactured before 2005. So you need an adapter converting from serial to Ethernet. And Softing also provides a converter like this. This is called the NetLink. It converts MPI to Ethernet. To set up the NetLink, you just need to select the baud rate as 187.5 kilobits. That's pretty much it. The front panel of the power line looks more or less always the same, but the X122, which we use for connecting to the power line, is always on the same spot it is right above the 8-digit display here. And once you have connected it, it looks like this. Yeah. So you will also notify, as I mentioned earlier, there are no Ethernet communication slots here, so we need a converter from serial bus to Ethernet-based communication. How to collect the data? Maybe you know that the Synomeric 840D, regardless of solution line or power line, consists of two parts. There's one part called PLC, and there's another part, the NCK. Typically, customer want to access both. They want to have data from the PLC and also from the NCK. And we need to tell the Edge Connector 840D which data you want. And this can be done via two different files. One is the SDFI file. This file is needed to access data in the PLC. And another file, another text file, which has the naming AWL file. This is needed for accessing data in the NCK part. Let's have a closer look how the file looks inside. If I enlarge this SDFI file, you can clearly see that data like, is the program running? Is the program stopped? Is it aborted? This data is available in data blocks, and you need to know the exact data block and also the byte where the information is stored. Also, workpiece counter can be found in the PLC, but as I said, you need to know where it is saved. Coming to the AWL file, you will notice that the structure is different. This means that the actual override has to be addressed differently. And in case of the NCK part, the address looked like this. And this comes from the NC-var selector, which I speak a little bit later on. Once you have these files created, you will load it into the 840D Edge connector, which will then collect the data. The next question, of course, how do I get the files? Yeah, there's an easy way. You can simply download the pre-configured files from our web page. Yeah, there's no additional tool needed if they met your requirements. But of course, if they don't meet your requirements, you can enlarge, you can adapt, you can change the files by using these different softwares. One is the data feed exporter, and one is the NC-var selector. So how to create the AWL file? If you don't like our default file, you can create your own one, and this is done by a tool called NC-var selector. This NC-var selector software is a software which comes from Siemens, and basically it's like a database where you select which variables you want to collect from your 840D. You can import our var file, which we also provide, and then you can enlarge it, you can add some variables, whatever you want, and the output of the NC-var selector is a AWL file. The same, more or less the same is for the data feed exporter. This is a software which comes from Softing, but again, you have to import your project. Like the S7 project of the Synomeric, or if you have a TIA project, you can import it into the data feed exporter. It will give you a drop-down or a list, and then you can select which variables you want, which you don't want, and export the whole list as an SDFI file, which you will later then import to the Edge Connector 840D. Basically, that's everything from the theory part. So I will hand over to my colleague Thilo, who is also going to present to you some theoretical inputs.
Thank you, Stefan, and welcome from my side. So I will shortly give you an introduction into what basically PeakBoard is. And for this, I will just shortly share my screen. So PeakBoard is a solution which you can use for creating industrial application very easy. So the idea of it is we've created a low-code application which enables you to create your own industrial applications. So this can, for example, be a dashboarding, like we will do it later for the connectors Stefan already presented, but you can also create application for collecting workers' data. You can create an application for whatever thing you want to do to make your workers and your plants available to work with the data in your systems. So for that, we have a PeakBoard box, which is our hardware. You can see here. So basically, things are working like this. We create this application in the PeakBoard Designer. The PeakBoard Designer will later in the technical part be shown by myself, and I will show you how this works. And when you've created this application, you will upload it on a PeakBoard box like the one you can see here. The PeakBoard box is getting the data from different data sources. This could, for example, be the edge connector from Softing, but this could also be, for example, an ERP system or whatever. And for that, we from PeakBoard can connect to all of your different data you have in your plant. So you can connect to your sensors, you can connect to your PLCs, SCADA systems, and so on. And when you did so, you can use our application to create, for example, a dashboarding or what we can see here, a quality control. So in that case, I just show you a small example how people can collect quality data. So let's say they want to select which parts are broken and which parts are fine to create data out of that, which make you able to evaluate where you have problems, where you can improve. And that's what PeakBoard basically is. What we will do in a few minutes is to create this application. So we will create a dashboard overview floor where you can see how is the current state of your Synomeric, but also how you can collect data from your workers to get an overview of your current situation in your plant. For that, I will hand it over back to Stefan to start with the practical part.
Thank you, Thilo. And I will start now with my practical part. So I have already opened up my Edge browser, and I've entered the IP address and the port under which the Edge Connector 840D is running. I have to log in, and then I come to the landing page, giving me some useful information about the version installed and who I should contact if I need any help. So the interesting part, because the time is limited, is the connectivity chapter, which is split again in MQTT and OPC UA. You can use both protocols, and for the styles connection made to the Synomeric 840D, you simply enlarge the controller tab. And I will add a new connection down to my Synomeric 840D. I press this Add Connection button. I will give it a name like Solution Line. And I want to establish connection to both, to the NCK part and to the PLC part. If you are happy with the default files, you can leave it as it is, but I have modified my NCK symbol file, and so you have to upload it. I simply choose file. I use that one specifically prepared for this webinar. I press open, and that's already it. Last thing I need to do is to enter the IP address of my Synomeric, which is that one. One short notice: if you want to connect to a power line, it is made the same way, but if you have power line, you need to go to the advanced settings page and change the so-called TESAP selections from solution line to power line. So this one you need to change, and this one as well. You will have further option in advanced setting like the alarms and the tooling access. I will show you later on what that means. By pressing save, the connection should be established. And as you can see, the plugs are now together. So I have made a successful connection to the NCK part as well as to the PLC part. Now I can provide this data via MQTT and OPC UA, but today I'm going to show you only OPC UA. So the Edge Connector 840D acts as an OPC UA server. So other clients, OPC UA clients, can connect to it and collect the data. It is possible to also enlarge the security of the OPC UA server. In my case, because it's just a demo, I'm using at authentication settings anonymous, and I also don't apply any encryption modes. But of course, in a real life scenario, this would be something that we recommend, and you can select that only data is collected in an encrypted way. And also we have IP access filter and access protection, which enlarge the security further. I will copy now my endpoint of the OPC UA server, and I have opened up already an OPC UA demo client, which is also coming from Softing. You can download it for free just to check if everything works fine. Unfortunately, or of course, you cannot visualize the data. Therefore, we have partners like Peakboard. This acts more like a testing tool, just to check if you made the connections correctly. And now you see that I can browse the OPC UA address space. This is split in two sections: solution line NCK, and the other one is solution line, the PLC part. Let's have a look what the PLC part provides. Let's open up this DB channel 1, and you see that I can see if the Cinemeric is running or not. These are tool variables where you see, okay, the program is running, it's true, it is not wait, it is not in stop, no one has interrupted or aborted the program. And also Thilo will cover this data items later in his presentation. When I open up the solution line itself, this is more or less the default ones. I've just made one enhancement. I added the workpiece counter to my AWL file. The rest is the same as the default one. So you will get the name of the program. You will see the line number, which is currently executed. You also will see what's the line content and which tool currently is used. Also from the access, you can see the access, the position of the access. And speaking of the drives, you can also monitor the current or the voltage or the temperature of the engine. Yeah. 1 minute before, I've activated the alarms in the advanced settings, and this allows you to also collect the alarms which are present on the Cinemeric. So basically you will get an array, and sometimes the text is not available, but oops, let me check. It says that it's a test and demonstration machine, and in a real life scenario, you will see here the error message which are currently present at the Cinemeric. We can also access the tooling areas, which allows you to monitor the different tooling types. Also, let's see what is in place 1. Let's see if there's if there is a tool, and currently on place 1 in the so-called Kettenmagazin, we have a Fräser, which is a German word for a specific tool, and it is actually monitored. We can see, okay, you can make 123 drills, and then you need to replace the tool. And of course, this is available for every place. Yeah, pretty much that's everything I wanted to show you. Thilo will now take over and will present to you how you can visualize the data.
Yeah, thank you, Stefan. Then I will jump back onto my screen. And now you can see the PeakBoard Designer. So this is the low-code platform we provide from PeakBoard. So this tool you can use to create your industrial applications. You can just download it for free from our website to get things started. So let's start from the starting page here by selecting here this dark theme. So then we just get over to the main screen of the PeakBoard Designer. And in our case, like shown before, we want to show to create this demo, this floor plan. So for that, I just start by adding the floor plan as a screenshot onto my PeakBoard Designer. For that, I've just simply provided a PNG file, which I can just drag and drop from the File Explorer directly onto my screen. Click here on OK, and now I've just added here a floor plan. So that's just where things starting. So the next thing I will do is first I will lock that so it doesn't annoy me anymore. I cannot click it now anymore. And the next thing I will do is now to connect to the OPC UA server Stefan provided from his Edge connector to get this numeric data. So for that, I firstly click here on data, add data source, and like you can see here from PeakBoard, you can connect to a lot of different data sources, starting from REST APIs like JSON, XML. You can get data from SAP databases, whatever, or different machine data, like for example here we have OPC UA. OPC UA is just the thing we want to use now. So let's start with that, and first I give that thing here a name, and we call this Cin1 for Cinemeric 1. This is our first of our Cinemeric machines, and firstly I will enter here URL of our demo server of our OPC UA. Let's click here on endpoint reload. So like also Stefan showed before, we have no authentication set, so I can just select here anonymous. However, I need to select any kind of certificate. I can directly create here, but I already did that. So let's click here on select, and that now gives us the possibility to click here on manage subscriptions, which allows us to search in the in this OPC UA demo server all the data we have. In that case, we just have this different numeric CLC machines, and I will just select all the values I want to have. In that case, these are the program running, waiting, stopping, and the workpiece counter. So let me just click here on select, and I can directly click here on top right on enable listener, which directly provides me the live information from the OPC UA test server. Let's click on OK, and now I've just added here on the left hand this Cinemeric data source. So now I want to show the data somehow. For that, I just start by adding such a rectangle from the top right on the position on my floor plan where I have my Cinemeric machine. So the next thing then is that I add a header for the Cinemeric. So for that, I just drag here from the top. Oops, I double click onto the rectangle, and I will just simply set the visual settings, like for example the position. I will call it Cinemeric, and just set the font here to header 2 in that case, and making a little bit smaller because it's pretty big here. and let's have it like that. So then to beautify a little bit, give it a border and set it here. And the next thing I want to do is show the counter. So like Stefan showed, we have this workpiece counter from OPC UA, and I want to show the number of the parts created from the CNC machine. For that, I add here another text field. Also, I center that one. And in that case, I just connect that to my data source I've created before. So in that case, this is the only data source I have. It's this Sin1. And I want to have the workpiece counter, which delivers me the amount of produced parts. Let's do another thing. We want to show here how the current state is of the machine. So if it's running or if it's waiting or has an error. So for that, I just add here such a small little ellipse. I set it by default to green, and if some things happen, then I will change the color of it. So for that, I just go here to this element, and here I have this property or this thing called conditional formatting, where I can create such kind of rules. Let me just start with the first one, and let's call this running. And in that case, I say if the Cinemeric is delivering me a true for the Boolean program running, then I want to set the color to green. Let's do the same for idle. So let's say it's stopped, but a planned stop. So then we have this program wait to on true, and in that case, I will just want to set it to yellow. And let's add one more, and let's call this arrow. And in that case, I get a Boolean true from the stop. And in that case, I want to set this color to red. So that's basically all I need to do here. But let's do one more thing. So let's say we don't have just the Cinemeric data, but also we have a workplace where some manual people are working, and they also should be able to deliver different states and parts. So let me just do one other thing, and here I will create two variables manually. The first one I will call workplace 1 and pieces. And this one should be of type number, and by default it's 0. And I go here to advanced, and I click here on this share with PeakBoard Hub, where I can give it identifier to later connect it to other applications. So let's call this workplace 1 and pieces. Click on OK. Let's just do exactly the same again for the state. So this one I will just call workplace 1 state, and do the same thing here just for state. So that's basically it, and we can now do the same thing like we did before. Just add here another one for the workplace. I will add another text here on top, and here I just call it workplace 1, and center this thing here again and set the font to the corresponding font. And in that case, I want to have another text on the bottom of this field. In that case, I want to show the pieces created manually on this workplace here. So again, I will just center it and add another ellipse here on the bottom right. So it's just doing exactly the same later like the other one. So let's move that one here to the bottom right of that part. Click it, and let's set the color to green again. And in that case, I go back to this conditional formatting, where I just add these 3 different states. In that case, it's just that one, and and we've defined that if it's 0, then everything is fine, and if it's 1, everything is fine, and if this state is 2, then we have an idle, so worker has just paused or something, and then we also have an error state here. I call this error, and go again here, and let's say this one is now 3, then I want to set this color to red. So, and to make this part also done, we already get the data from the OPC UA for that part, but for that part we need to collect the data somehow. So for that, I've already created a small other dashboard before, just like that. So in that case, I again have 2 variables connected to the other ones by just setting this, by just setting this identifier. In that case, it's the workplace 1 state, and oh no, I just did it for the wrong one for the pieces, and the same one for the state. And now I've connected these variables with the other dashboard. And here on these buttons, let's just open one of them. I just changed the values of the, okay, I've set it to 1. So let's just change it shortly. So when you click here on one of the buttons, this script is running. In that case, it's not really a script. You just can use our puzzle system, what we call building blocks, where we just set these different values. And we have one other thing. When you click here on done, then we count up this number, how many parts are created. We count it up by 1 by setting this variable to itself plus 1. And that's basically all we need to do here. So then I think pause with this fine with 2. And when I'm done with that, I can simply upload it on my workplace where I've installed such a PeakBoard device. In that case, I'm using such a Surface, so Microsoft Surface, where I've just uploaded this application to run it there. And when I now go back to my overview and click here on the top right on the preview button, then I will directly see how things are running. So we will now directly connect to the data from the CNC machine, getting the data here, counting up the numbers, and also I have here this manual workplace where I can directly interact with the dashboard to get an overview of the whole floor plan. To upload the current version. So by clicking here on this done part, I can just count it up or set here the problem. So now you directly can see where are problems happening. You can reduce your downtimes by reacting faster and get an overview of your plant. That's it from my side. So thank you.
Okay, great. Was really interesting. Thank you. I'm kind of looking to see what questions are coming in. So let me see. Okay, here's one for you, Stefan, about how can I test your software? Is there any way to try it out before?
I think I didn't mention it. So you can download the Edge Connector 840D for free. It is available under Docker Hub or also on Microsoft Azure, whatever you prefer. And it comes with a 72 hours demo mode. So you don't have to buy it straight away. Download it, test it for 72 hours. And after 72 hours, you can restart the application and it will run again for 72 hours.
Okay, great. Thanks, Stefan. And I have one question, which I think this would be for Thilo. Can I also clean the data in case I want to aggregate them or something similar to that?
That's a good question. It's very common that you don't get the data as you want to have them. So in that case, we provide something we call data flows. So you can just simply click on such a data source you've created, click here on process data with a data flow, where you have the possibility to, for example, filter the data or sort the data, aggregate them, or proceed the data however you want. So it's really made simple here to proceed your data so you can get it as you want to have.
Mm-hmm. Great. Then I have a question from Gerald Steinkellner in this case. How fast can I collect data from the CNC?
Yeah, I don't have a concrete answer to this because it depends. It depends what data you want to collect, how much data you want to collect, and from which machine. Is it a solution line? Is it a power line? So it depends a little bit, and it varies between, let's say, 10 milliseconds to 80 milliseconds. That's the range. And yeah, please contact us and we can discuss it in more detail. But yeah, that's just to give you an indication.
Mm-hmm. Okay, thanks, Stefan. Since we don't have any further questions, I would say we call it a day. Thank you, Thilo. Thank you, Stefan. This was interesting. As I said, we'll provide the presentation, we'll provide the recording. If any questions should come up after reviewing it, reach out to either Thilo or Stefan. We're there to help out, to answer your questions. And also feel free to look up our website, Softing Industrial, for upcoming webinars around the topic of connectivity. And I look forward to welcoming many of you in the future for, again, hopefully interesting and educating webinars. Thank you, Thilo. Thank you, Stefan.
Thank you.
And thanks to
to
everybody
Claudia.
out there. Have a great day.